Welcome to the Masterclass session on insulation and ventilation. My name is Christina Joby Maria. I'm a consultant at Turner& Townsend, and we are joined today by Gareth Field, Senior Consultant from Turner& Townsend. So this is a retrofit information, support and expertise event, which is fully funded by the Department of Energy Security and Net Zero and delivered by Turner& Townsend. I will now hand over to Gareth to start today's presentation.
Cool. Thank you. Good afternoon and welcome. So as Christine has mentioned, this is a RISE presentation and it's part of our Back to Basics program that we're running through August, where we thought it would be a really good opportunity just to kind of go back and just kind of revisit all the basics of retrofit and help kind of clarify some of those basic issues and make sure we've got the foundations right. So as we go through, it will be quite, the depth of knowledge is going to be quite limited, just kind of making sure that we've kind of got stuff really sort of dialed in around some of the basics. I guess I'm sitting here because I've been and done this. I've done the retrofit programming and delivery of retrofit programs within social housing and within the charitable sector in Cumbria here where I live. So I'm sitting here with my experience of delivering insulation, delivering ventilation strategy, and some of the challenges we've had with it and some of the experiences we've had from a social housing perspective. If you hear from a local grant perspective, some of the challenges will be the same, and some of the challenges around with especially ventilation is getting people to understand why do I need ventilation? You're trying to make my house more energy efficient. If you're of my age, you will have been brought up being unable to walk around the house because there will have been stupid draft excluder sausage dog things attached to every door that either stopped you from opening the door, or once you did get through the door, tripped over so that you then fall onto the floor in a huge embarrassment. So we've had this culture of you stop all drafts and you seal up all doors and make sure that we've got no drafts running through the homes. But actually now we're going back into homes and going, we need to cut a trim off the bottom of your door and et cetera, et cetera. And there's a culture change and there's a mindset change. So that's some of the challenges that we face within this. And we'll get to that as we go along. So yeah, thank you very much. So starting off with just a bit of an agenda of the session. Why do we need insulation and ventilation? What's its purpose? We're going to look at some different types of insulation, so real basics. What are the different types of insulation? How do you fit it? Different types of ventilation and what do they do? We'll have a look at what happens when it goes wrong, because there are lots of stories about there around insulation going wrong and ventilation going wrong. What's happened? Why have we got damp and mold, etc., etc. So we'll talk some of that, and then we'll cover some of the resources that we have that can support you with this as you go forwards. So why do we need insulation? It's homes have been around for millions of years, hundreds of years. Why have we got this focus now on getting insulation sorted? And most of our housing stock in the UK is old. Most of it is poorly built, sadly. Most of it is very, very drafty. And that draftiness, that transition of cold air to warm air, either through drafts or through transition through windows, walls, etc., make our homes cold, make our homes inefficient, make our homes expensive to heat, expensive to have nice, and affect your thermal comfort. And then what does that do? Well, that affects your mental health if you're sitting in a cold house all the time. I've got a friend at the moment who is buying a new house, and the thing he's most excited about is that he will be warm in his home. He has been trying to make his old house warm and comfortable to live in, but actually fundamentally he needs to go back to the structure of that house. So actually he's just decided to move house, and the thing that he's most excited about is having a warm home, being able to sit. Hopefully it's not true, but he said he wants to just sit in his pants around the house. I'm really hoping that's not true, but that's the kind of thing that happens is when you get people into warm homes, actually they're comfortable, they're happy, they're content, they feel happy in their homes rather than just sitting in a cold home. So as we do this work, as we do with insulation, we do think about the ventilation strategy. That's the background to it. It's actually making people more comfortable in their homes, happier in their homes, which has an impact on their mental health, which has an impact on their health and well-being, has an impact on the financial bottom line. So it's really, really positive. It's really important to get it right. From the other side of things, it's really important to get it right, because if you get it wrong, you actually make the house worse. You're going to get damp, you're going to get mold, you're going to get water running in your house, you're going to get damage to the buildings, damage to the fabric of the home, etc., etc. So it's fairly high risk. And the other side of this is I used to work in a National Trust, and when we worked there, we didn't talk about the life of a home in 20 years or a life of a building 20 years. We talked in hundreds of years. What are we doing to this castle to extend its life by hundreds of years? So that's the kind of mindset I always have around this, is some of this work that we're doing will extend the life of these buildings, and will extend these life of the buildings for a significant period of time. So we know we have a housing crisis. We know we don't have homes suitable and fit for purpose for people in these communities. We've got people living in B&B and people living in travel lodges because there is no accommodation available. So by doing retrofit programs, by doing insulation, by doing ventilation well, we make the property last longer, which hopefully will kind of reduce the number of homes that are sitting empty because they're not in a fit state. So, I live in a 1920s home here in Cumbria. We live on a slight rise. As soon as the wind blows, I'm in the process of retrofitting my home myself, but as soon as the wind blows, you can feel the wind whistling through the house. You can feel it coming through the underfloor, through the underfloor ventilation, which is there to make sure the floor is dry and etc. But wind whistles through and it's just freezing. So there's stuff that we need to be doing to kind of change that and change those old homes to make them more energy efficient. New homes are really, really well built, as in being airtight, being like sealed. But from a housing association, actually, we had a huge number of issues with homes that were under 5 years old that had damp and mold because there wasn't the appropriate ventilation in there. So, we were then starting to look at ventilation strategies for homes that were compliant with all the insulation, etc., etc. They just did not have the correct airflow in and out and the transition of air. Ventilation is not only providing that sort of fresh air for the residents, it's also reducing the buildup of moisture and volatile organic compounds. Not easy for me to say, so the VOC, so making sure that works for those buildings, that we're getting rid of any of those kind of toxic gases. The other side, and I was listening to this myself the other day, that we've got a really good podcast at the moment on radon. So if you live in an area of high radon, really interesting to think about how ventilation impacts on radon as well for our residents' homes. So something for you to think about if you live in a high radon risk area. Or if you've not thought about it at all, I sat there and really enjoyed listening to it as I was driving the other day. So yeah, really good podcast to kind of listen to and kind of get your head around radon and ventilation. So now within the changes to PAS, ventilation is in there. You have to be really, really kind of clued up to your ventilation strategies and get it right. Otherwise, it won't pass your PAS, and then all that work you've put in won't be doing what it needs to be done. So, a lot of stuff we've just covered there. So that increased air tightness. I don't know who else has got a teenage daughter on this call, but I've got one of those teenage daughters who likes that really, really large puffer jacket kind of coat thing, and she'll put it on every day. Even in the summer, she's like that big puffer coat on. And that's like this. When we insulate a house, it's like putting that big puffer coat on. But as soon as she cycles off into town, unzipping it, taking it off because it gets sweaty inside, etc. And that's the same thing with our homes. So by insulating the house, we're sticking one of those big puffer jackets on it. We're then living in it, and it's creating that sweaty, damp atmosphere, which is just unpleasant. You know what it's like in a coat. Just think about that in your house. So, we are doing the ventilation to reduce that, kind of make it more comfortable and stop that sort of build up of moisture and dampness. So just going to run through some different types of insulation. So, we're going to talk about loft insulation, floor insulation, cavity wall, external wall and internal wall insulation. So they are, they do different things. You use different resources and different materials for those different things. Some are really cheap, some are really, really expensive. So, we need to think about what we're going to do to our homes. And this is where your retrofit designs come in, and your retrofit designers being able to make sure they're doing the right thing and the most important things first. So, I mentioned I'm retrofitting my home. First thing was loft insulation, getting the loft insulation sorted up to 300 mil. But then also tackling the loft hatch. Let's not forget loft hatches as we're doing all this stuff. So you can put 300 mil everywhere else in your loft, and then have this cold bridge from the loft hatch. So what are you going to do on top of that? Things like that we need to think about. So yeah, and then we can also think about whether we're using synthetic materials or natural materials. So as I mentioned, up here in Cumbria, we've got this fantastic company that use Herdwick wool to create draft excluders for loft chimneys. So brilliant resource. And reusing the Herdwick lamb and the wool from the Herdwick lamb, fantastic resource. It's a great material and it's a great product. So, some really cool stuff coming along and some great stuff being made out of different materials for insulation, etc., to reduce your carbon footprint. So if your driver in all this is to reduce your carbon footprint, is what are those natural materials can we use instead of creating new man-made materials? So loft insulation, as it shows there, it's filling the roof with an insulatory layer. Mentioned it's about 300 mil is about a good depth to go to, and making sure it's not squashed. So that you're putting this 300 mil of insulation in, then you're not then putting your Christmas tree and your suitcases and your etc all on top of it to compress it down and make it useless, or make it almost useless. So making sure that if we are going to board it, that we're sticking those on stilts, so that actually the loft insulation can do its thing, and then we have boarding on top of that, so it's not squashing it down. Really key thing is the airflow must be maintained in the loft space to prevent the buildup of moisture. So if you block off all your around the eaves of your roof and you don't let any air come in, actually you're just going to get very sweaty. It'll impact on the roof joists, very damp, etc. So making sure there's still airflow above the insulation. So, you should be warm under the insulation, and when you go above it, it should be feel cold. It should feel temperature of the outside. Things to be aware of with this is thinking about any hot water, water tanks in your loft, making sure they're not going to freeze. So if they are above the insulatory layer, how do you do that? How do you protect that from freezing, etc. So it's fairly easy to install. It's fairly quick to install. You don't need to be at it for days and days and days. You don't need scaffolding, etc. You just need access into the loft space, and you need a loft space, as I've mentioned, with no boarding, no Christmas trees, etc. So pretty cheap, really effective, makes a huge difference. Definitely want to make sure, first port of call is the loft insulated to 300 mil. So pros of this: low cost, really great for kind of heat loss reduction. Some of the cons from it is, can you get in the loft? What is your resident filled the loft with? If you're talking social housing or local, any of this, as you're going, how much stuff is in there and where they're going to put it when they can't put it back in their loft? That might cause you your risk of no access. So actually, how can you work around that? It's not a task to be doing today on a 25-degree day. It's really hot. It's really sweaty. It's a really unpleasant job to be doing on hot days. Definitely want to be doing in the winter. So yeah, definitely thinking about that. And as I mentioned, water tanks there. Floor insulation. So this is about sticking insulation under a floor, so that if you have a floor that's on joists, so that your suspended floor, you can then stick insulation in between those joists to stop, partly to stop air transition, but also to create an insulatory layer. If you have a solid floor, like a concrete floor, it is harder, but you can still do it. Now, I don't recommend this, but two friends in Scotland are both about 5'6", so they just decided to stick the insulatory layer on top of the concrete floor and then stick a new floor down, because they just, they didn't have to lift the door frames. They just lifted the floor up towards the door frames, which is great for them at 5'6", but me at 6'3", I hit my head on every door frame in their house. But that's the approach they took, and I wouldn't recommend it. But that if you've got a solid concrete floor, you then need to build on top of that or cut it away and build underneath it. So it's your choice, but it can be done on solid floors. If you have got a suspended floor, you need to make sure the air bricks remain open to air coming in, so that actually the air can come in, and make sure that the joists don't get damp and wet, etc. So through humidity, etc. You will find a really noticeable improvement to the comfort of that building, especially if you've, like my room, the wind whistles through when it's blowing. So improves thermal comfort, makes it much more pleasant to be there, helps create that thermal envelope. Mention that coat over it. It's creating your kind of making sure the drawer cords tight around your waist, that it's kind of sealing up around your house. But it is really disruptive. You have to lift the floor. You have to then take, to do that, you have to take everything out of the floor, out of that room. You have to lift the whole floor. There are some robotic installations available, but they're not suitable for all homes, and they're not available for all homes. So you need to do your research and find out for that. Costs are significant. you are lifting a whole floor and you're replacing a whole floor. You can find new problems, obviously, which is not a bad thing, but you have to understand that there might be some contingency costs that you might need to plan for. And ensure there's no thermal bridges as you're doing that, so making sure you're getting it sealed off and kind of connected. Cavity wall insulation, this is really, really common, and you see this a lot in retrofit. It's not suitable for all homes, but basically you're filling the cavity between your walls with an insulatory layer, and it's like a bead now that sort of sets into it gets pumped into the cavity, and the beads kind of set together and kind of create that solid insulatory layer. It reduces the heat loss by creating that thermal layer in between the cavities. It does make the homes much more comfortable, much more energy efficient. Okay, so fairly easy to install for any other type of wall insulation. So you drill holes in, make sure it's clear, make sure it's clean. If you've got no insulation in there at all at the moment, and if not, you need to go and clean your insulatory layer out. It's pretty cheap to install, and it's fairly quick to install. Installers can be doing 2-3 homes a day, so kind of can be banged out really quite quickly. As with all these things, the quicker they do it, the more chance there is of a mistake. So it's really good to have some kind of testing process in after this. So maybe do sort of thermal imagery cameras before and thermal imagery cameras after. If a cavity wall has been done badly, you will see hotspots where it's not connected together, and you've got kind of hotspots where air will be, coming out, heat will be coming out of those rooms because the insulatory layer is not there properly. It can be really, really good, as I say, if it's done properly. So I won't be having this done on my house because my cavities are too narrow and they're too full of mess. So my house was actually built by my neighbour's father, so I know it's not great quality. So I'm not going to get cavity wall insulation put into this house. At some point, I'll be doing some internal wall insulations. The more and more you do this, by buying this in bulk, you can actually get some really good discounts with contractors, etc. Just doing one-off homes, can put the prices up, etc. Making sure that all this is done in a way to make sure that any ventilation can still be achieved, and there's some checks to do that there's no holes in walls or holes on this, because I have seen a number of cases now where rooms have been filled with basically cavity wall insulation bead when they didn't realize there was a hole in the internal of the house. So yeah, it can be really messy when that happens. Now, external wall insulation, this is about sticking an external insulatory layer on the outside of the house. So this can be done in a number of ways. We've got a masterclass actually on EWI coming up this month. So if you want to learn more about EWI, there's going to be a masterclass this month or next month where actually it's kind of goes in great depth. But basically you're on top of the house, you're sticking an extra layer around the house. And this is fantastic for extending the life of the homes, as I mentioned. But there's a huge amount of cost to it. There's a huge amount of impact on the house and the impact on the residents. So things to be thought through when you're going through this. It's also really, really good for solid walls. But again, you need to do the right tests and the right calculations to make sure you're not moving the dew point to the wrong place and causing a detrimental impact on the wall, the build of the wall. So great option for solid wall properties, and even in some conservation areas. I live, say, in Cumbria, and as you head out towards Yorkshire Dales, there is a home that has definitely had external wall insulation put on in a beautiful part, and it's been done really, really well. And it's only because I understand what I'm looking for that I would recognise it. Most people drive past it, it just looks like a traditional Yorkshire stone home. But it's been done so well. So it's fantastic. It can be really, really good. It looks great. You can change the outside of it. You can change what it looks like, etc. And generally you get a 25-year guarantee. But the condition of the house has to be right. You have to do lots of ancillary work, like you have to extend the eaves on the roof so that it kind of covers the top of it. You have to extend all your doorways and all your windows and all your doors, etc. because you're sticking another depth of onto the house. You have to make sure that the doors and windows and stuff are in the right place to actually benefit from this, and you're not just going to get water seeping inside because it's not sealing up. It's really good to kind of, if you're going to do this in relation to the other jobs that you're going to be doing on those homes. If you're social housing, if you're thinking about actually I'm going to have to replace the windows anyway, let's do it all at once. The other thing that is really at risk of this is people not realizing external wall insulation. So I've heard a couple of examples now where residents have tried to put hanging baskets, and basically they're drilling it into insulating panels and then hanging baskets on it, etc., and just pulling the panel off the wall. So you have to change how you live in the homes. You have to change how you are behaving around these homes, and things like drilling through for new pipes or anything, you have to make sure that you are sealing them up, just not creating a thermal bridge where the cold air can just go bypass that insulatory layer. So lots and lots for us to think about with that. It's kind of really important to kind of keep on top of any EWI and making sure they're doing it really well. Internal wall insulation, so as it says there, is insulating the inside of the house. It's taking, you can do it a number of different ways. Is here they've built a stud wall and they put insulatory, and then they're going to put a plasterboard on the inside there to kind of make it back to the inside of the house again. It can be done. It's disruptive to the home because obviously you're working inside that house. It can be really negative around the fact that it reduces the size of rooms and makes rooms much smaller. But again, can be a great opportunity for solid wall homes. So we definitely in Cumbria have a load of those where solid walls have had this internal wall insulation. So good option when there's planning or kind of issues around doing it externally. So I know one home where the plan had been to do external wall insulation, but actually the house's boundary was the wall. So then they were going to have to go on to basically the pavement, and they couldn't do that because they couldn't get permission to use the pavement. So they then returned to an internal wall insulation. It's great insulation. It does its job really, really well. Can be done one room at a time to reduce the disruption. It's definitely cheaper than EWI. However, you still need to do a lot of ancillary works. You still need to move radiators. You still need to move sockets, skirtings, carpets, etc., etc. You need to make sure the walls are in good condition before you start it. In some spaces, it's actually just stops it from being practicable. So if I was to do it on my staircase in my house right now, that would be fine. But in 30 years' time, when I need a standard stair lift, I wouldn't be enough width in that room, in that staircase, to put a standard stair lift. So I wouldn't be able to do it. So, the impacts now on reducing room size. If you're thinking about as a social housing provider, if you can't any longer get a bed into a room, it's no longer a bedroom because you've made that room smaller. The gain with all of these things is you need to be really clear with your designers. What are the materials you're using? How are you going to do it? And making sure that you're using contractors who are experienced in this and they're not just bodging it together. So quick run through of insulation there. I'm going to move on to ventilation. So we're going to talk about 4 different types of ventilation here. So intermittent extract ventilation, passive stack ventilations, mechanical extract ventilation, and the mechanical ventilation with heat recovery. So for intermittent extract ventilation, this can either be just having some vents in your room that just as it says there, the background vent, if you've got a leaky home, it just pushes air out or pulls air in as required. You can do that either through kind of cord holes, or nowadays a lot of places actually just having trickle vents on windows, which helps give you that background ventilation. You need cross ventilation between your rooms. So if you have insulated the outside of your house, you've created that sort of thermal coat. You need to have sort of door undercuts. This is where that changing behavior is of kind of moving away from having draft excluders, etc. And I will promise you will go out, and if you start talking to residents, they will have issues with you doing door undercuts. Just taking it like a quarter of an inch off the bottom of the door, or a centimetre or so off the bottom of the door to kind of so that air can move between the rooms. And then especially with older residents, it's actually getting them to change their mind about draft excluders, etc. You might also then put in extract fans. So you might choose just to have one that's on a timer. You might have one that's a humid static one, so that when it gets more humid in the room, it kicks in and ventilates that room. Definitely in wet rooms, definitely in kitchens, definitely in anything that is where you're going to create lots and lots of moisture. So don't forget things like utility rooms where you might have a tumble dryer or something. You might want to have an extractor fan in there as well. Passive stack ventilation. So actually it's just by having, as this sort of basic idea here, is tubes running from the rooms up through the roof and out through the roof. That's either through chimney or through kind of ventilation in the attic. This is great. It kind of say that hot air, that moist air can get out of the house, and the air's coming in through either through trickle vents or specific ventilation systems. They are really, really good, but it's very hard to retrofit this because you then need to put in loads of pipe work and loads of etc. into your house. So this friend who's moving that I mentioned earlier, he's going to do this in his new home because he's doing a bungalow. So actually it's much, much easier to do in a bungalow than it is in a 2 or 3 story house, etc. So you can have lots of your trickle vents, but you need to make sure they're proper size trickle vents. Are they given enough? And all of this stuff will all come back to what your ventilation strategy says. And is there enough air coming in to feed, for the number of people living in that home, for the kind of appliances you have in that house, etc. So mechanical extract ventilation is about having those extractor fans that are sucking air out. They can be running 24/7. They can be just, continually pulling air, the damp, moist air out of those rooms and extracting them out into the outside world. You need it to be fairly well airtight. I'm continually having this argument with my daughter at the moment. We've got the extractor fans in our wet rooms, but she just keeps wide, opening the window wide. And I'm like, all you're doing is pulling air through your window, through the extractor fan and back outside. It's almost like a circular thing. So actually, when you're doing this, you might think about, I need to make sure the windows are shut, etc., in the wet rooms. So you're not pulling air from the outside to then send back outside. So intakes through trickle vents, etc. So all very much like we've been talking about, it's there. It's very much mechanical. This is where we need to factor in anything like that radon conversation I had. This is, again, a really good understanding that if you're in a radon area, you might already have ventilation strategy associated with the radon. You then need to redo that ventilation strategy in relation to the retrofit and radon. So those two things got to sit hand in hand. And this is the piece of resistance. If you can get this, some kind of mechanical ventilation with heat recovery. So really easy to do on new builds, much, much harder to do on retrofitting. But there are some systems coming out now where you can do this per room. So I say old house, right up there, I've got a really, really big air brick, and it's really, really big air brick and lets loads of cold air in the winter, etc. What I've been, Housing 25 this year, talking to an extraction company, and they're creating this system where you can suck air out, but they capture the heat, and then they blow, kind of pulling air in and heating that air in from that heat that's just been used. So it's a single room mechanical ventilation with heat recovery. So there are systems that are coming that will make this better and better on a room by room basis, which I'm really kind of interested in personally for my house. Just kind of triggering this is, so we've mentioned PAS a lot. So this is one of the requirements for every dwelling proposed for improvement. A retrofit designer shall use the information provided by the retrofit assessor to assess the adequacy of the existing ventilation. So what's in there, what's already there, is it doing the right job? Is it enough? We need an acceptable, complete ventilation system in that home. So these are the things that we need to be fitting into any homes that we're retrofitting as we go along. So what happens when it goes wrong? So Fishwick, unfortunately, Fishwick's one of those things that it gets pulled out every time. It gets pulled out as the example of bad practice. But there are lots and lots of examples of bad practice out there, which is a real shame. And that's where PAS has come from, and that's where we're working really hard to increase education and get people thinking more about retrofitting homes, and upskilling the workforce is really, really important. So it was about £5 million spend. I believe the fitting, the cost of repair all this work is much, much above £5 million now. But basically, defective installation, no design, no ventilation strategy was put into these homes in this retrofit, which has led to widespread damp and mold, but also water running down and damaging brickwork, and impact on the kind of the fabric of the homes, making them unlivable in. And it's a huge problem across all these homes. With all this, it was supposed to make their lives better and was supposed to make it cheaper to live in these homes and healthier. People with bronchial problems, etc., from living in these properties. So, efforts have been made to correct these issues. Current cost of remediation, there goes, estimated at 6 million. So it's more than was spent doing it in the first place. But it's all the other things that are there, the cost of the health, the well-being, the mental health of the residents. We've got a great podcast on the Fishwick stuff there, so it's a great chance just to kind of listen to the guys who are in there doing the repairs on it and what they're doing and how they're doing it to make sure they're doing it properly. But some brilliant stuff on there about resident engagement, because you've got a load of residents who were told they were going to have this amazing stuff and it ended up with water pouring inside their homes. So all the trust has gone. So actually their resident engagement has had to be top notch to get in the doors, to get it working, and to get the kind of the buy-in from the residents. So really, really useful, really great podcast again. So there we have really quick overview of all the different, well, some different types of ventilation, some different types of insulation, and how they work together, and the importance of making them work together. So some key things from me is kind of making sure that your retrofit design is looking at the house, making sure you're thinking about the number of people who are living in there, how they live in there, kind of cooking utensils, etc., they've got, so that they're creating the right ventilation strategy for that home, how people are living in it, rather than just a tick box exercise of, yeah, there's a ventilation strategy, we need to put some extractor fans in. And the other thing, as I've mentioned, is, you know, that learning I've recently had around radon is making sure that any radon works that have been done in the past is embedded within future ventilation strategies. It's really, really important, and really a kind of key thing that we're kind of holding on to for all our retrofit work. Grand.